In 10.5, there's going to be some math again. Earlier sections in Unit 10, I told you there was no math in some of the problems that you did. Like for vertex form, if you knew what H and K were and you did opposite same, you didn't have to do any math. You could just graph it and figure out where the vertex lies, whether the A was positive, it opened up, or A was negative, it opened down. In 10.5, though, we're actually going to be doing some math, some adding, subtracting, multiplying, and dividing. And most of this stuff is going to return to normal algebra type of math. What we're going to be doing is we're going to be taking those equations that you had, and what we're going to do is we're going to figure out where they touch or intersect the x-axis. That has several different names. They are called intercepts, they are called roots, and they are called solutions. I have seen it. I say, hey, find the intercepts. You would do it this way. If it says find the roots, you still do it this way. If it says find the solutions, you still do it this way. There are three different ways to write the same type of problem. Before we get into how we're going to do the math, the thing that I need to remind you that you may or may not have been taught up until this point. If you have a variable squared equals a number, like x squared equals 4, it has two possible answers. 2 times 2 is 4, and negative 2 times negative 2 is 4. There are two possible answers when you have an unknown thing squared equaling a number. Because of that, because there's a positive possibility and a negative possibility, we are always going to include a plus or minus sign when square rooting a quantity squared. Meaning, if you have x squared equals 4, and part of your math is to get rid of the little 2, you do the opposite, which is square root and square root. You have to remember, when you square root this squared, there is going to be a positive or a negative possibility for that square root of 4. And so you write a plus or minus sign so that you don't forget there's a positive and a negative possibility. In my honors class, I talk about how the square root of x squared is the same thing as the absolute value of x. You guys don't need to know that per se, but since I do have some people in this class that are very, very bright, I do want to show you some things that come from honors. And this and this are equivalent, which is another reason why there's a positive and a negative possibility for those answers. When you give your answers, we're going to give our answers in a solution set bracket. That's these things. It means your answer is either this answer, -1 or 2, or both, -1 and 2. And we just make these nice curly brackets. They're called curly brackets or braces, believe it or not, like the thing on teeth. Curly brackets or curly braces. There you go. That's they has both names. So here's what we're going to do. We're going to do these 5 steps in most of these problems. We're going to try to figure out getting the quantity squared. That might mean this group squared. We want that by itself by moving the constant to the other side and dividing by a. So we might move this over first by doing the opposite. We might have to divide by a secondly. We might have to square root both sides, and don't forget the plus or minus sign. Get the variable by itself and simplify and rationalize if necessary. So these are the steps. If you are a person who likes to keep their notes out while you do your worksheet, these 5 steps are going to help guide you on how to do most of the problems. The last thing I need to say before we get into examples is this. If you try to square root a negative number, it doesn't work. Matter of fact, your calculator, if you did it on a calculator, it would say square root of -4 doesn't exist. It says error. It's not a real number. Technically, it's an imaginary number. And I don't know if we're going to cover it in this unit. I don't think I've seen anything in Unit 10. I think it's going to show up in 11, but I haven't seen the worksheets for 11 yet. I think we're covering it in maybe 11.4. That's just a guess. I have no idea. But for right now, if you ever square root a negative number, you say or write that it's no real solution, or this symbol means no solution right there. A 0 with a line through it. Okay? So with that being said, you have the worksheets in front of you. I have number 3 chosen to do part A, B, and C. Then I have chosen 8, 10, 12, and 18. We're going to do those problems together. If you would like to do them with me, you are welcome to do so. So number 3, part A says, solve the equation for x. I want the x by itself. Now, if you don't know what to do, you go back up here and it says isolate the quantity squared. This is the quantity squared right there. I want to get that by itself. First thing I'm going to do is move this plus 8 to the other side. The opposite of adding 8 is subtracting 8. If you did that, 8 minus 8 makes 0, goes away. This would be negative 2 quantity squared, x minus 3 quantity squared equals negative 8 on this side. You do the opposite of adding 8, you subtract 8. I still want to isolate the quantity squared. I might have to divide by a. The a value is the thing in front of the quantity squared. This is multiplying x minus 3 squared. The opposite of multiply is divide by negative 2. I'm going to divide by negative 2. 2 divided by 2 is 1. Negative divided by negative is a positive. 1 times anything is itself x minus 3 squared. You're getting this quantity squared, this x minus 3 in parentheses squared. I call it a quantity because it's a group. Equals this divided by that. Negative divided by a negative is a positive. 8 divided by 2 is 4. Once you get here, your next step says square root both sides. One. Yeah, help. So, square root both sides. When I square root both sides, the opposite of a little 2 or squaring is square rooting. I'm going to do the opposite. But I have to remember this is a quantity squared being square rooted. There are 2 possibilities. Don't forget that the square root of 4 has 2 possibilities. Positive 2 times positive 2 is 4, and negative 2 times negative 2 is 4. So I'm going to put a positive possibility and a negative possibility there. Don't forget it's plus or minus 2. That's the most common mistake. These two things sort of cancel each other out. You're left with the x minus 3. There's only one more thing to do. You want the x by itself. You need to move this 3 over. I need to add 3 to this side. This makes x is equal to 3 plus or minus 2. Now that can be simplified. You could do 3 plus 2. 3 plus a 2 and 3 minus a 2. 3 plus 2, let's write that. 3 plus 2 is 5 and 3 minus 2 is 1. Those are your 2 solutions. We write our solutions in a solution set bracket from smallest to largest. 1, 5. It's either 1 or it's 5 or it's both 1 and 5. That's what that means. Part B. It says graph this function. So now what you have to do is you have to remember what we learned in section 2, vertex form, because this is vertex form. You should know where the h and the k are in this. That would be opposite same. Opposite of this is 3. Same of this is 8. And so I should know that if I go to the right 3 and up 8, 1, 2, let me put 3 right there. 1, 2, 3, 4, 5, 6, 7, 8. 8's right there. My vertex should be at 3, 8. I know that this has a negative 2a value. The a value, because it's negative, it opens down. And so I have an idea that my parabola is going to do something like this. It's my guess. It has to be narrow. Remember, thin, narrow, because that's a 2. It's skinnier than a normal parabola. And then part C says, where can you see the answers from part A in your graph? So let's look at part A and let's look at the graph. See how it says 1, 5 right there when we said this equals to 0? We're figuring out the x's. These two places, 1, 5, are the places where this parabola touches the x-axis. These are the roots. These are the intercepts. Mathematically, what we did is we put a 0 equals that answer, that equation. We could figure out where it crosses. Graphically, that is your x-intercept as a part of your graph. So where can you see the answers from part A? The x-intercepts are my answer. And that's how we're going to do a lot of this stuff. You're going to start off with the graphing stuff, and then they're going to skip the graphing, and they're just going to say, solve it. Figure out your x-intercepts. So let's jump to number 8. I want the quantity squared by itself. Move the minus 7. Do the opposite. Add 7. Add 7. It's negative 7, positive 7 makes 0. The 5 is multiplying the x squared. Divide. Do the opposite of multiply. Divide. And now you have this weird fraction, but that's okay. That's why we taught you fractions a long time ago in 5th grade and 6th grade to get you ready for high school mathematics. You're going to do the same exact thing that you did before. Get rid of that little square. You square root, but don't forget the plus or minus sign when you square root. Put the plus or minus sign in front of that radical. These two things go away. X is equal to plus or minus the square root of 7 over the square root of 5. I can split this square root of the top and the bottom. And then what you have to do is step 5, which says you may have to rationalize, meaning get rid of that square root in the denominator. This is something we haven't done since probably unit 10, unit 11, I think it was. No, what unit was it? Where we started rationalizing. Times by square root of 5 over the square root of 5. That creates the pair. The 5 pops out. Inside times inside makes root 35. So it's a plus or minus root 35 over 5. Solve the following equations. We did. It's a positive or a negative root 35 over 5. State the number of x-intercepts for the related quadratic function. How many x-intercepts are there? There are 2. This is where we rationalize. Something we haven't done in a while. Now what happens if there's a fraction in the problem? Let's look at number 10. Number 10 I chose because it has this 2/3. I still try to get this by itself. I still add 5. 2/3 x squared equals 5. But instead of multiplying by 2 over 3, you can divide by 2 over 3. Divide by 2 over 3 is the same thing as multiplying by its reciprocal. It's the same thing. 5 over 1 times 3 over 2 is the same thing as 15 over 2. Just leave it as a fraction for now. You could switch it to a decimal, but there's no need. Now to get rid of that little square, the opposite of square is square rooting. When you square root something squared, it's two possibilities, a positive and a negative possibility. So x is equal to plus or minus the square root of 15 over the square root of 2. We've got to rationalize now. Pair, 2 pops out. Root 30 on top. These are our 2 possible answers. How many possible answers? There are 2 answers there. A positive root 30 over 2 and a negative root 30 over 2. That's where the x-intercepts are. Don't freak out if there's a fraction in it. Use it. Leave it as your answer. Number 12. Yeah. If you have a quantity squared, there's nothing different about it. You'd still just add 10 to the other side. You get rid of that little square just like you've been doing. The opposite of a square is a square root. But because you have a quantity squared, there's 2 possibilities, a positive possibility and a negative possibility. Don't forget that. That's the easy thing. Now there's no fraction here, which is nice. These 2 things sort of cancel each other out. You're left with x minus 3. You almost have the x by itself. Now this answer is going to look a little bit funny, but I need to get the x by itself. I need to add 3 over here. I'm going to put the 3 in front of this plus or minus sign. X is equal to 3 plus or minus root 10. You cannot put them together. Root 10s can only be added to other root 10s. 3 can only be added to other constants. This is not a constant. So these are my 2 solutions. 3 plus root 10 and 3 minus root 10. The last example I have for you is number 18 because I figured we might as well do a word problem as well. And get you ready for it. A ball is thrown vertically upward with an initial speed of 96 feet per second. That's just there to confuse you. Its height after t seconds, that's telling you that the variable t is measured in seconds, is given by h for height is equal to negative 16 parentheses t minus 3 squared plus 144. After how many seconds will the ball hit the ground? How many seconds? Seconds is t. You need to figure out what the t is. In your language, I heard somebody, that means something totally different these days. The variable t, not the t. Oh, you know the t about blah, blah, blah? I've heard that. You guys use that in the weirdest way. T meaning like gossip. You guys use that as the word gossip now, right? Like, I don't know. Golly, what's this? I don't know. Okay, anyways, I got distracted. I distracted myself. I apologize. After how many seconds will the ball hit the ground? When it hits the ground, it is how many feet off the ground. The height, when it hits the ground, is going to be 0. And that's the key to solving this question. The key to solving this question is that the height is going to be 0 and you need to figure out what the t is in mathematical sense. In a mathematical sense. And this is what we just did. We can figure out at what t value will this have a height of 0. So we subtract 144. Just like we did before. Negative 144 equals negative 16 t minus 3 squared. Since this is multiplying, we divide by negative 16. I'm going to use my calculator for that. 144 divided by 16 is 9. I get rid of this little square by doing the opposite. But when I square root something squared, I have to remember there are two possibilities, a positive possibility and a negative possibility. I bet you guys know what the square root of 9 is. Oh, don't forget the plus or minus, still there. Add the 3. So you have 3 plus or minus 3. And so that means your two places where the height is going to be 0 is going to be at 3 plus 3 seconds or 3 minus 3 seconds. It's going to be at 6 seconds or at 0 seconds. And so if you think about it, something being thrown up, its height is 0, and then it returns to 0 6 seconds later. That means it's gone up. The highest point is at 3 seconds. It goes 144 feet. Like, that should all match up to you. That should all make sense. We're going to stop your notes right there.